Okay, so I have my MIDI device here, and it's connected to a battery, and this battery has these we call dimmer that's connected to a small keyboard, and this keyboard is connected to this MIDI device, and this MIDI device connects to my laptop via USB. So I have a code that I want to show you. It's ohwhatfun.glitch.me, and we're gonna let it run. So notice how it's detecting the MIDI device that I have, and if I hit play and if I press one of these buttons right here, I don't know if you're hearing some sound. It's a little bit mild, but that sound is coming from that MIDI device, from this code right here. Let's see if I can get the sound louder. It recognized the pitch and the duration, and you can hear that sound a little bit. Okay, so looking at the code, this is what it looks like. See if we can get that loaded. So first you say navigator.request MIDI access, and then once you have the MIDI access, you would connect to the input, connect MIDI input. Okay, where's that connect MIDI input? Right, sorry. There, it says MIDI access that input, it grabs the value, and that's what you would use, whichever gets selected. So once you have your MIDI input, and then you would have these MIDI message, you would create an event listener, and then connecting through that event listener, you can decode that event. So every time you receive an event from the device, it would go through this, and you would identify what type of to turn on and off the note, and you get the pitch and then the velocity based from the data. Okay, that is a good start. Let's go back to the presentation. So webMIDI, 75% of the browser, it is available out there. 75% of all the users, it's available in all the browsers that are Chrome, Edge, Firefox, and Opera, and also Chrome for Android, Samsung Internet. So it'll work on the Android phone. Okay, so let's move forward to what is Bluetooth. Bluetooth is a standard specification for wireless communication. It allows electronic devices to connect and interact with each other, typically short distance, less than 10 meters or 30 feet. But now Bluetooth 5 has a maximum around 800 feet, so it's getting better. It got started by Ericsson back in 1994 to replace RS-232. The original name for Bluetooth is Short Link Radio Technology. It got its name back in 1999, and there is a Bluetooth special interest group that has more than 20,000 members. A little bit of fact, this might be a little bit older. There's about more than 10 million Bluetooth devices that are shipping every day. That's a lot of Bluetooth devices if you think about it. Just a fun fact, the symbol Bluetooth, it looks like this, the one on the right side, is a combination of this Norse runes alphabet, HB corresponding to Harald Bluetooth, which is a 10th century king of Denmark. He actually helped get different tribes or different kingdoms in Denmark to unify them. So that's why Bluetooth is unifying all these different devices and communicating with them. 3.0 versus 4.0, classic versus Bluetooth or low energy, Bluetooth low energy. The classic one needs a session, has to be connected all the time. Remember those days? If you have to put a PIN number in order to connect to your Bluetooth device, and those are Bluetooth classic device, and they are voice capable. The Bluetooth low energy, it's either on and off, and there is no voice. It's just data back and forth. It has fast communication by about 3 milliseconds, and also has a capability to have beacons. So in that way, you know how close you are to that device. In order to understand Bluetooth, you have to understand generic attribute profile, sometimes called GATT. There is a peripheral, which is the server. Think about the peripheral is the peripheral device, and then central is your client. These are the ones like your laptop, your phone connecting to a peripheral. So if you think about it, your headphones or your some of these Bluetooth device acts as a server. To think about it kind of like a web service where you have a service and then characteristics. So understanding each one of the characteristics that you can connect to, kind of think about it as the URL, and then you have your path to that URL, to that service, and then you have parameters that you pass in order to communicate. So you can either read, write, notify, subscribe, or indicate or acknowledge. So there's different types of predefined GATT services. A lot of the most common ones is the battery service. So it's kind of like a pattern that some of device manufacturer, if they implement it, the client or the client services or the ones that's trying to connect to it at least would understand and have a common communication values. But lots of devices depends on what they implement. They may implement something custom. So it really is, depends on the manufacturer of that device. There is a toolbox out there. It's called NRF Toolbox. It's an app on like Android phone that you can use in order to understand more of how you would connect to these Bluetooth devices. And if you want to learn more or experiment on other Bluetooth devices that are available around you, I recommend downloading this and testing it out. So webBluetooth is a way to control BLE, Bluetooth Low Energy devices, directly from the web. It's only HTTPS, so it's security first. Devices have to be paired before you can interact, and it prompts you for user interaction, and then it's promise-based API. So it's only available through navigator.bluetooth, and it requires, like I said, user interaction, a button click in order to connect to it, and then you have to specify the filters and device name that you're interested in. So how you would use web Bluetooth API, a device needs to be paired first before Chromium can connect, and then you scan for relevant device, then you connect to it. Then once you were able to connect to it, you get the services that you're interested in, and then you get the characteristics that you're interested in, and then you can either read, write, subscribe to each one of those characteristics. We are going to use microbit for this. Microbit is very easy to use if you wanted to learn more about hardware, or it's an educational tool for lots of makers. So finding a matching device, you go through step 1, navigator.bluetooth.request device. In this case, we were filtering out the name prefix BBC microbit, so it only shows the ones that are BBC microbit on our screen, and then it filters out only ones that are the LED service. So we're gonna I'm gonna show you a demo where it would prompt this screen. And then step 2, you would use device.gat.connect. Once you got connected, you get the service, and so you need to know the service UUID. And you can, it's a constant value depending on what device you're connecting to. And then once you do that, you have to get the characteristic UUID, and you have to connect using that. And then now you can start reading the values and displaying it, or you can write values to a device. Just a little tip, you can actually use Chrome://Bluetooth internals to see all the Bluetooth devices that is around you. Okay, let's go do some demo. Okay, so I have these Bluetooth device. Let me show you here. I'll make sure I connected it. And it's this one right here. See if I can focus a little bit more. Okay, it is connected through USB, and this is a MakeCode device, and I programmed this MakeCode device to show whenever it starts the Bluetooth LED device, and then whenever it connects, it will show the string C, and whenever it disconnects, show the string D. I use MakeCode in order to program this device, and the cool thing is there's a JavaScript way of how you would do it, and it looks easy enough to play with it. So if you have a microbit and you want to program JavaScript on this device, you can do that. And there's lots of tutorials on how you would use MakeCode and microbit together, and how you would do this. So anyway, I'm going to focus on how you would connect these to this Bluetooth device right here. So once you have that programmed on that device, I created a screen right like this, where I can click connect. Let me set this up real quick so you can both see the device itself. So when I click connect, notice how it prompts, and notice how it only shows microbit. Even though I have lots of Bluetooth devices around me, it only filters that because I specified. And you would click pair, and once you click pair, notice how it says C on this device. Now that my device is paired to this, I can click on one and it sends that command. And I click this command, and it's just sending those values, And what it's doing is actually writing all the check marks here and sending all the bits, which one is on and which one is off, every time I have some changes here. Cool. And then of course I can disconnect. Okay, so let's look at the code real quick. Make that a little bit bigger. So remember I told you about the LED service. You have to do your research on whichever device you're connecting to. You have to know these constant. So think about it, the same way as whenever you're trying to connect to a web service, you got to know the URL, and you have to know the path to that URL, to the path for that service, and then you have to know the parameters in order to communicate. Same way as each one of these devices, you have to understand, like in this case, this LED service constant, and then the matrix service, or yeah, so the LED matrix state, you need to be able to do that. So first you do navigator.bluetooth.request device, and now that you have a target device, then you can connect to it. So in case this GATT Bluetooth device.gat.connect, and once you're connected to that server, you have to get the service, the LED service. Once you're connected to that service, you get the characteristic. So that LED matrix state is a characteristic. Once you get the characteristic, then you can send data to it. In this case, I'm just sending and writing values to that characteristic. All right. So this code is available for you if you want to analyze them later on. So let's go back to the presentation. So webBluetooth, 75% of all users, webBluetooth is available. It's available through Chrome, Edge, Opera. Unfortunately, Safari and Firefox does not support webBluetooth. Chrome for Android, Samsung Internet, Opera mobile, Android browser, Baidu browser. It is available there. Okay, let's move forward to what is USB. USB is Universal Serial Bus. It's a standard type for connecting different kinds of devices, different peripherals, wired peripherals. It became a standard, de facto standard, and it was co-invented back in 1994 by Intel and USB Implementers Forum Incorporated. Most likely you've seen a lot of the different versions of USB throughout the years. Nowadays the latest one is USB 4 that can go transfer data up to 40 gigabits to 120 gigabits. The ones before that, of course, it's less. Super speed USB, high speed, full speed. Yeah, up to go back to USB 1.0. Different types of USB. There's Type A, Type B, and now the latest one is Type C. There is a micro USB and a mini USB in between. Also, most likely you have all these connectors or some of these multi-use USB device converters. The latest version of Type C, notice how you can plug it and flip the connector and it still works, because you have 50-50 chance of the past generation of the past USB cables. They're always 50-50 chance of getting it right. Now they've improved it to where you can plug in, but depends on the manufacturer of that cable. Sometimes they didn't implement. They only implement one side of that specification. So yeah, doesn't work all the time. Depends on the cable. On this USB, the logo, it looks like this, and it is actually patterned against like a trident, right? So you have these three stems going, three forks, right? Let's have a trident fork, and notice how there's circle, triangle, and square denotes different peripherals connecting to your device, and they're becoming standard. Anyway, interesting logo. So how you would use webUSB API? First, you have to understand how to be able to use the USB standard, and then of course the cross-origin resource sharing to filter out what can and can't connect to that USB. First, request the device, then you would connect, then you select the configuration, then you claim the interface, then you control the transfer, and then you can start transferring data back and forth. It's a little bit more complicated than the other ones we've had, webBluetooth and webUSB. So I'm also going to use microbit on this. The webBluetooth a while ago, notice how there was a cable on that webBluetooth. The cable is just for power. But in this case, we're going to use the cable to connect it to the USB device. So for the webBluetooth one, even though when I demoed it a while ago, it has a cable, I'm just using the cable for power, but not for data transfer. For this webUSB connection, we're using the cable for power to the microbit device and also data transfer. So how you would use it, you would use navigator.usb.get devices to get the list of devices. And then in order to connect, you need to know the vendor ID and then the product ID. In this case, that's the vendor ID and the product ID for microbit. And then you do navigator.usb.request that device, and then you will get the correct device. And once you have the device, you can begin a session using device.open and then device.select configuration. In this case, you're selecting the first configuration there, and then you claim the interface. And once you claim the interface, you can you need to understand how to do the control transfer. There's different control transfers that are available out there. You can request, and you have to understand these values. And once you have those, and then you can transfer the data. And you also need to specify some values also in order to receive it properly. And then you can loop through and get the data in. Little tip, if you wanted to know what are devices that are connected to your machine, if you go to chrome.://device log or chrome://USB internals to try it out. So let's try that out. I think it's interesting. So chrome://USB internals. So notice how USB internals, you can click devices. These are all the different devices connected via USB, and you can inspect them. In this case, let's see if it'll show some of the devices are here. You can inspect, let's say, a video, and then it would tell you the version number. You can get device descriptor, some of the data that you would need, the vendor ID, and understanding what are the things you can connect to, what is the configuration. So some of them you have to study and understand what these values are. There's also, USB device log, right? So chrome://device log. And so this device log, every time you unplug and plug in a new device, typically it shows up here. It does auto refresh. See if it would refresh. Maybe it didn't auto refresh. So notice how I unplug a BBC microbit and it shows up now. If after I unplug it and then plug it back in, it gives me the serial number and GUID for that device. So it's interesting. So Chrome, was it device, USB internals. Let's see if we can find that BBC microbit. Maybe it's not showing up here for some reason. Oh, there it is. ARM BBC microbit. You can inspect. You see the class of device, get device descriptor. I know the vendor ID and the product ID based from here. I can get the configuration. There's that interface 0 and interface 1. You know, all these different values. So webUSB descriptor. Anyway, it's trying to understand each one of these values. That's the tricky part. Okay. Oh yeah, then also there's Bluetooth. Since I didn't demo the Bluetooth a while ago, there's also Bluetooth internals. And these Bluetooth internals, you can actually get devices that is available out there that you can plug in. So let's see if I can plug in a Bluetooth device. I can scan. So notice how it says BBC microbit. I can inspect it. It gives me the services that are available on that device, the ID, and then UUID. So you can start experimenting. What are the characteristics that you can connect to this device and what it can do and cannot do. So of course, knowing what these characteristics are for, what maps to each one of these, trying to understand that. Okay, so let's go back to webUSB. I'm gonna connect my device again. So for this webUSB, I'm using the make code also. So this is my make code device, or this BBC microbit BBC device, and it's also, I use make code in order to write to the serial value, the serial port, and the serial port, is just picking a random number and writing these values X, Y, graph data, so that it would just send some values, random values to the serial data. So using this, of course, JavaScript wise, it looks something like this, right? So randomly getting those information in. Okay. And then I would connect to this web USB. And I would click connect. Notice how it prompted me that I'm going to be pairing to this Bluetooth, no, not Bluetooth, this BBC microbit, and I would click connect. And now it started to send data from these Bluetooth device, or I keep on saying Bluetooth, from this microbit device. It's just sending those and then displaying it on the screen. I can notice how on the browser itself, it tells you there's the icon that says a USB port is connected. So if the window has a connection to USB and it's using it. You can clear the console and start sending that data. And then I'm going to disconnect. And that's it. So this code, I found it at this bcver/microbit on GitHub, /webUSB on GitHub, and I believe he's using a library called this DAP.js to connect to the webUSB. And in order to connect to this, you have to know the vendor ID, the product ID to get the data properly connected. Okay. Some resources if you want to learn more about how you would connect through webUSB. There is a webUSB code lab that you walk through how to do this. 74.99% of browsers of users out there have access to webUSB using Chrome, Edge, Opera. It's not available on Safari and Firefox. It also works for Chrome for Android, so you can connect it through that, and Samsung Internet, Opera Mobile, and all that. Of course, microbit, you can use it to build robots like this and to control that. There's also a Wio terminal that you can connect to Edge Impulse. Edge Impulse is a way you can do some machine learning on these low-powered devices. And in order to connect data, on this Wio terminal, it was using webUSB to send data to Edge Impulse. I thought that's an interesting use case for this. Of course, MakeCode is also using webUSB. You can use webUSB in order to send firmware data or to program a microbit device. So I thought that's a good application of webUSB using MakeCode in MakeCode. Other connection, another ways to connect is you can use the Web Serial API, and this one specifically for serial devices. There's also webHID, which is a higher level of abstraction than webUSB and webBluetooth. In order to connect, an HID only works for HID input and output device. There's also webNFC. This is an ability to read and write NFC tags using Android phone via Chrome. It's very limited to, it's not encrypted and all that stuff. If you want to connect to and get my presentation, you can go to owhatfun.glitch.me. You can use this QR code. I thought this is an interesting QR code because it looks like a small board, and so that is a valid QR code you can scan. And as a summary, webMIDI is the easiest way to learn and pick up, as long as you understand the MIDI message format. webBluetooth, make sure that you have to pair the device first, and however you pair your device to the machine before you can even access to it on the browser. And of course, you need to learn a little bit about GATT and what it means. And then through webUSB, you can do. In order to do webUSB, you have to understand the USB standard and how it connects and how you would communicate to that device. Microbit and Microsoft MakeCode is an awesome learning tool to develop on these devices, on some of these devices. And then Glitch really makes it easy to create and share and remix projects. That is it for me. If you want to learn more, my name is Ron Dagdag. I'm Director of Software Engineering at Spacey. I've been awarded 6 years in a row as a Microsoft MVP. The best way to contact me is at Ron Dagdag or on LinkedIn, LinkedIn/in/Ron Dagdag. I appreciate you spending time with me, and happy holidays. Thank you very much. Have a good day. Bye.